When I do that now, we have the image here and I can write on it. So first thing it says is name 3 collinear points. That's points on the same line. So if I look, here's a line. Do I have 3 points on that line? I do. So name 3 collinear points, point D, E, and F. Do you see another combination of 3 points that are what we call collinear? How about here with line K? Do you see 3 points on line K? I see points B, E, and C. So what we're looking at in this picture, and I just want to stress this, is that you have plane M. Plane M is flat, okay? And what you have is line K. B is above it. That line is going through plane M, touching point E, and then it's going through the bottom on the other side, which would be point C. It's like if you take a lid, which would be your flat surface plane M, and you stuck a straw through it. So next, if I want to name line J in a different way, well, we said that we can name a line by its fancy lowercase letter, or we can name it by any 2 points. So we just have to pick any 2 points that fall on this line. So I can call this DE. That what's special is over the top, we need this line segment, or that line over the top with the arrows. I can also call this DF if I wanted to, because D and F both fall on that line. Or what other combination do I have? How about EF? I can also do it backwards. I can do line FE, line FD, or line DE. Next, it says name the plane in 2 different ways. So if I want to name this plane 2 different ways, well, the easiest way to name a plane is by its fancy uppercase letter. So here's my fancy M, so we can call this plane fancy uppercase M. Or I can name this plane by 3 non-collinear points. So I just have to pick 3 points on this plane that do not fall on the same line. So what about ADE? We can call this plane ADE. Well, if you look, there's a bunch of combinations. I can use AEF if I want it. I can do DAF, etc., etc. There's a lot of different options. You cannot use point B and you cannot use point C because B and C do not fall on the plane. B is above the plane, C is below the plane. Okay, next question. Name the line containing BC. So point B and point C are right here. What line do they fall on? Well, the easiest answer is line fancy lowercase k. But since we're talking about BC, we can pick any 2 points on this line. So I can say line BC with the arrow over the top of it. It doesn't matter, however you want to look at it. I can call it BE, I can call it line EC, I can call it line CB, and so on and so forth. Okay, if I want to name 3 non-collinear points, I just pick 3 points. It doesn't matter which ones as long as they're not on the same line. The 3 you cannot pick are D, E, F, and you cannot pick B, E, C. But I could pick B, E, F because those 3 points will never form a straight line. So point B, point E, and point F would be a good example. There's plenty of other examples on there. And then finally, where does the plane M, that flat surface, and line K touch each other? Where do they intersect at? Well, they intersect here at point E because that straw hits the flat surface at E. To put this back in our notebooks, we're going to hit Control-Shift F4. We're going to take a screenshot of it. We're going to say copy to clipboard. And when we get out of here, we're going to hit Control V. When we get out of there, we're going to hit Control V. And there it is. If I want to do the second part of the guided practice, and I want to go ahead and take a screenshot of this, we're going to hit Control-Shift F4. We're going to highlight what we want to take with us and take a screenshot of it. When it pops up down here, we're going to say Annotate Image, and the image pops up for us. So guided practice, our points V, W, X, and Z coplanar. Hopefully you can see that point Z is above the plane. V, W, and X both land on, all three of those land on plane are that flat surface, but point Z is above it. So are all four of those points coplanar? The answer is no. And the reason is because point Z is not on plane R. So name plane R in a different way. Well, if I want to name plane R differently, I have to pick 3 points that are non-collinear. So what 3 points are non-collinear? Well, I got 4 points on here, V, Y, X, and W. Well, I just have to pick 3 that don't form a line, which really is any 3. So I'm going to pick V, Y, W. Can you think of another combination? What about W, X, Y? That would work. And so on and so forth. There's lots of different combinations there. Name the intersection of plane WXZ. So WXZ is this side, WXZ. It's this whole side of the pyramid, it's that triangle part, okay? Or which is sitting above. Well, where does this triangle touch the flat surface? Where does it touch? Hopefully you can see down here, it touches at W and it touches at X. Well, we said that 2 planes will always intersect at a line. Good job. So actually there's a line here that's not drawn in. So where the 2 planes intersect, they intersect at WX with a line over the top of it. You're essentially looking for the 2 points that fall on both planes. And we know Z doesn't fall on plane R. So name 3 non-collinear points. Well, that's any 3 points. So I can literally, what if I picked for my 3 non-collinear points? Any 3 points that don't form a line. So I'm going to pick those 3 points, V, Y, Z. Do they form a line? No. So those are what we call non-collinear, not on the same line. So the last part of the guided practice here is how many planes appear in this picture? Well, how many planes appear is the key word. How many planes do I actually see? Well, hopefully you can see 2 planes. We have plane P and plane Q. This is like 2, if you hold up your palms, but you don't touch them together, your hands, your palms don't touch, you actually have 2 planes that are what we call parallel to each other. They're not touching. One is on one side, one's on the other. They're parallel. They'll never touch each other. So it says our points D, F, and G coplanar, D, F, and G. At first glance, you would say no, because D is on plane P and FG is on plane Q. Well, you have to imagine actually these 3 points will always be on a plane because I can connect a piece of paper that can touch point D, point F, and point G. There's actually a plane here that we don't see that connects those 2 planes. So the bottom line here is that whenever you have 3 points, 3 points will always be coplanars. The answer is yes. 3 points are always coplanar. Name the intersection of line L and line M. So I'm going to come over here. I'm going to look for lines L and line M. Here's line L. Here's line M. Where do those 2 lines intersect? Well, we said 2 lines always intersect at a point. That's going to be point E. And I use the letters P, T to represent the word point, so I don't have to keep writing it out. 2 lines always intersect at a point. 2 planes always intersect at a line. Don't forget. Okay, over here. So our points D and E coplanar, even though they appear to be on different planes, because they're 2 points, I can actually connect them, right? So there is some plane out here in space that's connecting those 2, D and E. So the answer is yes. Same reason as part B. 2 points always are coplanar. Okay, last but not least, how many times do plane P and plane Q intersect? And as we discussed, they're parallel to each other, so they intersect never or none. Okay, because the two planes are parallel. Control Shift F4, we'll get this back into our notebook. We take a screenshot of the area that we want to take a picture of. Copy to clipboard, go back, and press Control V. And there we go, it's in our notes. So now that you've completed your guided practice, on the very last slide, I've given you a Quizlet, so you can go ahead and use that. It's like flashcards. I've already made it for you. You just go ahead and use it. Or you can look at the notes if you'd rather look at the notes in a PDF form. So your assignment tonight and exit ticket is to study these words.